Hello, guys.
Why is there?
Hello. Solomon Harris, Paul Mustang, Rodriguez, Nathan Light, Will Hostetler, Gage Levine, Elias, Alex, Queen Hart, Margie.
Sir, I'm here.
Where is Elias?
I'm here, sir.
No, sorry. Ismail, I'm sorry, my boy. Ismail Taylor. He was not there in the first class too. In Calc 2 class, where is he?
Right back there.
Okay, I think he's not here.
Didn't he say he's not going to be here Tuesday and Thursday because he had, or Thursday and Friday because he had to move in or something?
Thursday and Friday? Oh, wait, that's what he told? I forgot.
I don't know. I didn't know if that was him, but I know someone said that.
Oh yes, sir. Today's the day I have to leave early.
I remember that thing. Yes, I know that thing. But right. But I think what? Yeah, he's anyway. Okay, guys, how are you doing? Did you go over the stuffs we covered yesterday?
Yes.
All of you?
Yes, sir. Got it.
Good. Yes. Show it to me, one by one. Alex, go ahead. Turn the page. Yep. No, I can't see you. Keep it straight. Okay.
All right. Is that good?
Yep.
All right.
Second. Elias.
I'll go. Can you hear me?
Yes. Yeah, I can hear you. Show it to me. Keep your pages closer to your screen. Close your screen, please. Please be ready, guys. Please.
Oh,
Next is, I can't hear you. I can't hear you, Elias. Please go ahead.
Sorry about that, sir. It's right here.
Got it. Go ahead. Next. No, I want to see your pages, please. Next page.
Here you go, sir.
Oh, okay, fine. Next page. Okay, good. Next. Will Hostetler. I want to see oh my gosh, bunch of pages. See his style. Okay, I trust you. Gage Levine. Yeah, I can see your pages too. Paul Mustang. Oh yeah, I'm good. You're good. I'm sorry. Then Nina.
Yes, sir. Yes, sir.
Pages. Be ready. Okay, next page. Yeah, good. Next one is Nathan Light.
Sure, I still do mine second. It's right here.
Okay.
It's like 5 pages of it.
Makes sense. Good. Solomon Harris. Queen Heart, be ready. Solomon Harris. Okay. Heart. That's fine. Harris, fine. Heart. Next page. Heart. And Margie. Where is she?
She needs to say something.
Okay. No, I can't see you. I can't see your pages. Keep straight, please.
Sorry. Did you see any of them?
This makes sense. Yes. No, I didn't see any of them. Yeah. Let's start from the beginning. Okay, good. Next.
In the back?
Mm-hmm.
That's what.
Sounds good. Thank you. Okay, guys, I like your spirit, your work. I appreciate. That's good. You will really enjoy if you're working with me. Okay, guys, now let me start the last part of our what? 311 and chapter number 4. Last part. System of differential equations. So we are not solving now just one differential equation, but we are solving the system of differential equations. System, I mean to say that at least 2 differential equations. Please look at over here. Yeah, it's a very small, today's class is really very small. Yeah, we can start the new chapter if you want, but let me first finish this one, then I will decide. So dx by dt, x is the dependent variable, t is the independent variable, that is equal to 3y. Look at over here, x and y, 2 variables are there with t is independent variable. So 2 dependent variables and 1 independent variable.
So you're not sharing your screen.
Oh, I'm sorry, man. I'm sorry, guys. Thanks for letting me know this thing. Thank you.
Sir.
Is it okay now?
Yes, sir.
Good. So system of differential equation. dx by dt equal to 3 of y. X is dependent variable, t is independent variable. You have another dependent variable, y also. Look at here, guys. So independent variable d by dt, that stands for your operator t. Always d by dt, independent variable, that is your operator. So, and dy by dt, look at over here. Again, another equation that is in. So x and y are related over here. X and y are related over here too. 2 separate equations. X and y both are dependent variable, t is the independent variable. So I can write my first equation. It's very easy, guys. It's just like your, I would say, 8th, 9th grade problem. Only thing is, instead of algebraic numbers, we are working with the operator. That's the only difference. Otherwise, it's exactly same. You will realize this thing. So dx equal to 3y, dy equal to 2x, like this. I want to write x below x and y below y. So I'm writing dx minus 3y equal to 0. And then after I'm writing this 2x first, so negative of 2x on the other side, plus 3y equal to 0. Right, guys? So you can see here, x below x, y below y. Once you have this one, then try to solve these 2 equations. Just like your algebraic equations, keeping in mind that we are working with operator d. So here, suppose I want to cancel first y. If I want to cancel, either way, first x, first y, either way. So if I want to cancel, suppose y, I have to have d over here because I don't have d over here with negative 3. So negative 3 dy, and here I don't have negative 3. So let me write negative 3 or 3 here. So if I multiply this by d, I'm going to get negative 3 dy. Whole part is d square x minus, you cannot multiply just with one factor. You have to multiply throughout the equation. So d square x minus 3 dy equal to 0, negative. And here it is, if I multiply this one by 3, I'm going to get 3 dy. So plus and minus 3 dy will get cancelled out, you get here. So what is left out here? D square minus 6x equal to 0. But this d square minus 6x, now forget about the other part. Please just pay attention here. D square minus 6 square x equal to 0 is nothing but just your differential equation in the auxiliary form. I want to say operator form. So I can go for the auxiliary form of this differential equation. I'm not thinking about the other part right now. Just look at here, left side. So d square, my auxiliary equation is m square minus 6 equal to 0, so m equal to plus or minus 6. Roots are real and distinct. First category. First category means solution is c1 e to the power root 6t plus c2 e to the power negative root 6t. It has to be t here, guys. Please make sure, because t is the only independent variable you have. Right? Only independent variable you have. Okay, so xct, because my right hand side is 0, complementary function itself will work as a solution. So let me write xt. Why xt? Because it's a function, dependent variable is x. So actually I would write not the small x, so let me write small x over here. It is to be understood that we are working with this small x t as a solution. Now let me go to other side. Other side, that means now I have removed my y over here. I eliminated my y here. Now I want to eliminate my x. If I want to eliminate my x from these equations, I don't have 2 here. So let me multiply this by 2. See, I wrote it down here. Let me multiply this by d. I wrote it down here. So 2dx minus 6y equal to 0, negative 2dx plus d square y equal to 0. This will get cancelled out. D square minus 6y equal to 0. Y is the dependent variable and t is the independent variable for this one. Auxiliary equation will be m square minus 6 equal to 0, m equal to plus or minus root 6. Here, fortunately, we are getting like this, but it doesn't mean that every time you will be getting d square 6, this same auxiliary equations. No, it could be different too. So my roots are real and distinct, and that's why my yt or yct is only used two constants over here. You are not supposed to use the same constants again. So c3 e to the power root 60 and c4 e to the power negative root 60. If you remember, I told you order of the differential equation that must be equal to number of constants, right? Right? Here my order of the differential equation, or I would say other way around, number of equations. How many equations are there? I have two equations over here. That means I have to have two constants, but unfortunately, but I have four constants over here, 1, 2, 3, and 4. That means I need to convert either my C1 and C2 in terms of C3, C4, or vice versa. Don't say C1 with C3, no. Either it should be C1, C2, or C3, C4, or vice versa. Just a kind of pairing. It's simple. How can you do this thing? Let me do like this. Let me pick any one of these two equations. Choice is yours. Any one of these two equations. Let me say this or this one. Choice is yours. I told you. Dx equal to 3y. If I take dx equal to 3y, I don't know what. Yeah, I chose the same one. Okay, dx equal to 3y. D stands for the derivative operator. Derivative. X. X is this one. Take the derivative of this solution operator. This is slightly new additional portion. Derivative of this solution operator. Solution. xt. So root 6 c1 e to the power root t minus root 6 c2 e to the power negative root 60 equal to 3 times y. Multiply your solution y by constant 3. So 3c3 and 3c4 means you are getting something like this. Look at my line, this one, cursor. I have e to the power root 60, e to the power root 60. So I can either send this factor to other side, and e to the power negative root 60 and 60 over here. So I can send this factor to the other side. So I am just collecting the common coefficients. So e to the power root 60 out, and root 6c1 minus 3c3. Look at here. And here it is 6c4 and root. If you are converting c1, c2 in terms of c3, c4, now you can use for both of these factors, you can use the zero product rule. A times b equal to 0, either a equal to 0 or b equal to 0. But exponential function never be 0. You don't have any other choice. Means it is root 6 c1 minus 3 c3 equal to 0. Agree? And same here, root 3 c4 plus root 6 c2 equal to 0. So therefore I can write root 6 c1 minus 3 c3. So 3 c3 equal to root 6 c1 and c3 equal to root 6 by 3 c1. Root 6 divided by 3 c1. And c4 equal to like this. So I converted. See, I told you, don't take c1 equal to c3 and then c4. No, you have to manage the pair. So c3 and c4 I'm converting to c1, c2. So C3 is in terms of C1, C4 is in terms of C2. Go back and plug that values over here in your Y, so that now C3 will be in your C1 terms, C4 will be in C2 terms, everything that is in terms of. Write down both the equations separately as your general solution. So your solution will be YT equal to this one, XT equal to this one, and you are done. Simple. Just solve two equations. Then after go for the solution. You are getting 4 constants, convert to constants in terms of other 2 constants. That's it. And you are done. Simple. Any question? Just look at this solution twice. Look at this solution twice, guys. And if you have any doubt, you can ask me, but I don't think so. Yeah. Look at that one. I give you 2 minutes. And then after we will go for the next one. Done. Let me scroll some little bit. Look at this one. Look at this one. Okay, guys. So let's go for the next example. Make sure in these examples, guys, only thing is my right hand side equal to 0 in both the equations. But suppose I give you some constant. Suppose dx plus dt equal to 3y plus x square, 3y plus sine t, or t square, something like that. Not x square, t square actually. Or dy by dt equal to 2x plus 3t, something like that. In that case, you will be having your non-zero right-hand side. Non-zero right-hand side means you are not just finding your complementary function, but you are finding your particular integral too. And complementary function plus particular integral will give you the answer for xt, and same here for yt. Not just complementary function, particular integral also you need to find using your method of indeterminate coefficients, undeterminate coefficients, article 4.4. Right? So for both of these parts, you are finding complementary function, particular integration, addition, and then after you are getting xt and yt. And then you can convert your constants to the terms. Are you getting me, guys? And that's why out of those 3 examples in the practice test, first and third example, they are just with right hand side 0. Second example, right hand side non-zero. I can do one favor for you if you want. I can promise you that I will not ask you that non-zero right-hand side example, at least for simultaneous linear equations. But I want that example in the homework. Because homework, you are not time bounded. In the exam, I know you are time bounded. So I can do that favor for you if you want. What do you prefer? Does it matter? Okay, that's good. And I can ask anything. Okay, thank you. Second example, QC. QB I have not solved. That's the homework for you. Same thing, guys. Here the equation itself is given in the operator form dx plus d plus 2y equal to 0, d minus 3x, so x below x, y below y. And I don't have 3 minus d minus 3 here. And I don't have simply d here. Same here, I don't have 2 here, I don't have d plus 2 here. So if I want to eliminate x first, that will be multiplied by d minus 3 here, and here is d. So I can eliminate this one. If you multiply this one, so d square minus d plus, minus 6 and plus 2d outside y, so d square plus d minus 6y equal to 0. Right hand side 0, auxiliary equation, m square plus m minus 6 equal to 0, so m equal to 2 and negative 3. Roots are real and distinct. C1 e to the power 2t, C2 e to the power negative 3t. Please pay attention. It has to be t over here because t is the only independent variable you are working with. Same here. Suppose I want to cancel my y, means I have to have 2 here and I have to have d plus 2 here. So if you multiply like this, you can cancel this one out. You are getting almost the same thing over here. Same auxiliary roots, auxiliary equation, auxiliary roots, real and distinct roots, C3 and C4, e to the power 2t and negative 3t. Convert this one to this term. Pick any one of these 2 equations. Any one of these 2 equations, dx plus d plus 2y equal to 0. dx means derivative of your solution operator x. And d plus 2y means d plus 2 derivative of this one plus 2 means multiply the solution by 2. Other way around, actually. X is here, Y is here. Okay. So derivative of X is here. 2c2 e to the power 2t minus 3c3 e to the power negative 3t. And you can write here, or you can send it to the other side. It's your choice. D plus 2y, derivative of y, that is 2c1 e to the power 2t, negative 3c2 e to the power negative 3t, plus 2y. 2 is multiplied by y. So throughout you can multiply it by 2. And that is equal to 0. Collect the same power and its coefficients. Same power and its coefficient. A plus b equal to 0 means a equal to 0 and b equal to 0. A times b equal to 0 means FOIL method. Either a equal to 0 or b equal to 0. 0 product rule. Exponential function never be 0. C3 equal to 2c1. C4 equal to this one. Go back and plug this value in your solution and you are done. X equal to this one and y equal to this one. You need to write both the solutions like this again. Any question? How many of you are taking this course second time, guys? Please be honest.
This is my third time, sir.
Who is that?
Gage, sir.
Gain. Okay. Then third time. Any other guy? Oh, he's the only one? Nina, this is first time I know. Margie, this is first or second time?
First time.
First time. Okay. Solomon Harris, I think it's for you too, right? Yeah.
First time.
First time, yeah. Okay, that's okay. Okay, Gain. So listen to me, Gain. Gain, I forgot the name.
Gage, sir.
Gain, right? Yeah. Where is he? Why I don't see him?
I'm right here, sir.
Okay. Look at me. If you have some doubt, I want you to clear this course this time. You know about your performance, but I want you to clear this course this time. I don't want you to repeat now. And that's why if you have some doubt, just let me know, okay? Anytime.
Yes, sir.
You're okay? Anytime, yeah. That's just for you. Anytime, you are most welcome. Just let me know this thing that you are facing this problem and I'll try my best to get back to you. Sounds good?
Yes, sir.
And follow my sentence, follow me every time. If I give you follow my instructions. If I give you something, please try to finish in time. And if you have any doubt, please keep your doubts aside and you will be given the first priority in our review session daily. So if you have any doubt, you can ask me any kind of any rubbish questions. You can ask me 2 plus 3, okay? But please clear all your doubts and try to clear this course this time. Sounds good?
Yes, sir.
Okay, good. Okay, guys, so I think that is it. This is the end of this syllabus or this chapter, and this is just half an hour, guys. So I think we can't waste our time. If you allow me, I can do one thing. I can give you half an hour for review session, and then after, or other way around, just allow me to start the new chapter for half an hour, and then we can start the review session. What do you prefer? Our first review session?
I'd say we can start the chapter because I have to leave, but if no one else wants to, it's fine.
Say again?
I would say start it because I would have to leave at the end of it.
Okay, I know. So you want to start the...
I'm good with that.
You want me to start the review session or...
Say chapter first.
Chapter?
Chapter first, please.
Chapter first?
Yes, sir.
What do you mean by chapter first?
Like start the new chapter first before the review.
Oh, okay. I'm sorry. So yeah, before the review, we can start the new chapter. Okay, guys, that sounds good. Let me do one thing. Let me stop sharing this screen and let me go ahead with sharing the new screen. So let me start class notes and chapter number 5. Where is it? I don't have it. That's not fair. Okay, let me go back. 311 and I'm going to post the practice test and everything probably tomorrow for the new chapter. And test 1, 2, 3, 4 and the practice test chapter 1 and 2 practice test chapter practice test spring and 5, 7 and 8. Okay. Sorry guys. Practice test solution. Practice test. Okay. Let me just double check. Oh, this is just a practice test. Where is my class notes for this chapter? Test 1 to 4 and assignments for assignments. Oh, ridiculous. Why this chapter is not there? Give me some time, guys. Oh my gosh, I have to scan the pages or I forgot, I don't know. Let me just try to make sure. Practice test, here it is simply a practice test. I think I forgot to scan the pages. Oh my gosh. I had everything over here. Where is it? No, I did that thing. Chapter 5, that is the application Spring Mass System. And we are going to see different kind of applications based on Spring Mass System for second order differential equations. And but I don't have that one with me right now. That is ridiculous. Chapter 5, chapter 2, chapter 3, 4, and 5, 6, 7. I took it over here. Just let me check my email, guys. It was there. What was the date on last Friday? Will you please let me know, guys? What was the date on last Friday?
I think it was like May 30th, I believe.
May 30th, okay.
29th.
I think it was the 29th. Yeah.
Yeah,
It was
29th.
29th.
Let me share my screen now. Modeling with higher order differential equation. Sorry about this, guys. We are going to learn only 3 articles from this chapter because I just would like to let you know how the second order differential equation is being used in a practical life, practical problem. Spring mass system. First one is free undamped motion. And then after we are going to see the damping force too. First is free undamped motion. Suppose I have one spring which is clipped over here at one end and other end is free. And the length of the spring, that is L, small l. This is the unstretched position. We are not doing anything with this string, Ilyas here. Newton's law says that force equal to mass into acceleration. Mass into acceleration. So I have one end of the spring is hang at one end is hang, and the second end is free. Second end of the spring is free. If I put some weight over here on the second end, here, free end, if I put some weight, if I put the weight, because of that weight and the gravitational force of the spring will be pulled out little bit and it will go down. It will go down. And then after it will come like this. And then after some times, it will come to the equilibrium position. So spring will be moving in the vertical direction like this, right? At that time, the restoring force will be working on it. After some time, it will come to the equilibrium position. I don't do anything. I just put some weight and leave it. Now, the weight is, this is my second situation. This is my second situation. I put some weight. So length of the spring is stretched to some length S. And then after it will come to the equilibrium position. And this equilibrium position is given by mg minus ks equal to 0. mg minus ks equal to 0. Now, this is my equilibrium position, that is L plus S, length of the spring because of this weight of the object M. Spring is stretched a little bit and the stretching is given by S. So S is nothing but the stretching. M is the mass, G is the gravitational force. Now, if this is the situation now, earlier it was just a spring, length of the spring, now L plus S, stretching the spring due to mass M. Now I give some force like this, external force like this, external force. Again, spring will move like this, right? So that is again more stretching will be there because of the external force, and that is called the motion. So L plus S, this equilibrium position that is here, and more stretching over here that is given by X. That is your X. Hooke's law, as I told you, Hooke's law says that F equal to Ks. Here K and S, this force is nothing but this is called the restoring force. This is your restoring force. S is the elongation, and K, whatever K I mentioned over here, that's a spring constant. That's a spring constant. Or the way around, you can say that your force is directly proportional to the elongation of the spring. Force is directly proportional to elongation. That is the Hooke's law. That's what Hooke's law says. One simple question: if mass weighing 10 lb means 10 lb, m equal to 10 lb, 10 lb, 10 pound, stretches a spring half feet. Because of this mass, the spring, length of the spring is now stretching to half feet. Then what will happen? Mass weighing 10 pound, right? So F is equal to Ks. Mass weighing, that is the force. So you can write that F equal to 10 K as it is, and stretching, elongation, that is the half feet. Elongation, the stretching, that is half feet. So that means K equal to 20 lb per feet. You have to mention the units. Sometimes in the homework, you guys have not mentioned your unit. Yesterday I graded your homework. 3 guys have not submitted their homework. So I gave them 0, 0. Other guys, they submitted the homework and I graded your homework yesterday. I found I did not mention, because if I mention, I need to cut your points. I did not mention. Most of you are getting almost full 80-90% in the homework. But some of you, I would say almost all of you except one. That's not meant, all of you have not mentioned that unit. You know, one electrical circuit 3/5 ampere. You guys forgot to write that ampere. Please make sure, guys, make sure. Anyway, so Newton's second law says that. Now, this is just the example of the Hooke's law. That's fine. Newton's second law. Newton's second law says that weight W is balanced by the restoring force, right? S is the elongation. But this weight, when this spring mass system comes to the equilibrium, because of the restoring force, because gravity is pulling down the spring in the direction of the gravitational force. But the restoring force, because of the restoring force, it moves up. And after some time, it comes to the equilibrium position. After some time, it comes to the equilibrium position. So That's why we are using Newton's second law over here. Weight W is balanced by the restoring force Ks. So W is equal to Ks, that is okay. But W is equal to actually mg. W is equal to mg, right? W is equal to mass into gravity. And that is equal to Ks. I can take this Ks other side. Say mg minus Kx equal to 0. That is the force. Mg minus Ks equal to 0. But we know that by Newton's second law, mass is nothing but, force is nothing but mass into acceleration. So mass into acceleration, that is m of a. In my case, here what will happen that it is k into s. F equal to k into s. But actually it's not s. Actually it is s plus x. See, once you give some force, that means the stretching the spring, that is some little bit more, and that is x. So that's why it is k times s plus x. So now F equal to ma. Again, I'm using the same equation. F equal to ma or ma equal to F, and F equal to mg minus ks. But this s is nothing but, as I told you, k times s plus x. So s plus x. So finally, actually our spring mass system works with this equation. So F equal to mg minus ks minus kx. But mg minus kx, you can see over here, the equilibrium position, it is 0. So this part is 0. That means we are getting F equal to, or ma equal to negative of kx. Negative of kx. What is this? A is the acceleration. Acceleration means second derivative. Second derivative means d square x by dt square with respect to time. So m d square x by dt square equal to negative of kx. Negative of kx. Look at here. Negative of kx. If you take this kx other side, on the left side, this and divide by m throughout, you are getting d square x by dt square equal plus k by mx equal to 0. And spring mass system, you can see over here, ended up with the second order differential equation where this k by m is nothing but your omega square. This is your omega and angular velocity, you can say. And this type of motion, that is called the simple harmonic motion of the spring. Simple harmonic motion. So d square x by dt square plus k by m, or omega square x equal to 0, where omega is, it is omega square x. Omega is written in the form of square root of k by m. Simple harmonic motion. And simple harmonic motion with period. There is some period. It can't cross certain level, right? It can move between these two. There is some period. That period is that's called the angular velocity. That period is 2 pi by omega. And the frequency is given by 1 over the period. 1 over capital T, that's a frequency. And capital T is equal to 2 pi by omega. So if I ask you to find the frequency, that means I'm asking you the reciprocal of the period. That means it is 1 over T. That means it is omega over 2 pi. That's the frequency, right? So all they are interconnected. Omega is nothing but, if you want to find omega, you have to take help from the spring constant and the mass. So k divided by m square root, that is the omega, always positive. That will provide you, if you divide that one by omega, 2 pi by omega, that will provide you t, reciprocal of the period t, that is the frequency. So always spring mass system is nothing but the second order differential equation. And that's why I just would like to consider your article 5.1, 5.1.1, 5.1.2, 5.1.3 from your book of chapter 5. The rest of the things, they are good. They are okay. First question. W equal to 2LBN like this. Before I start first question, I just would like to let you know what is my first question. Okay, so I need to go back and I need to find the another form. Let me open my another file. So let me go back. And let me open my another file. Nine, 10, no, not this one. Look at here. Can you see my screen?
Yes, sir.
My screen?
Yes, you can.
Yes or no?
Yes.
Okay. Look at here, guys. This is a practice test 4, last practice test. Chapters 5, 8, and 7. Intentionally, I would like to jump to chapter 8 after chapter 5, because chapter 5 is higher order differential equation. Chapter 8 is again, system of differential equations. So you will not be solving just one differential equation, but you are going to solve 2, 3, 4, 5, 6 differential equation at a time. So just in a continuation, I would like to jump to chapter 8, and chapter 7 is completely different than your course. That is called Laplace transform. It has no relation with any of the previous chapters. Okay, example number 1, 2, 3, 4, 5, 6, 7, 5 and 6. These are the examples for from chapter 5. Chapter 7, example number 7, 8, 9, and 10 are the examples from chapter 8. 11, 12, 13 are the examples of chapter 7, Laplace transform. Eigenvalues and eigenvectors. This is the formula sheet. You need to take the printout of this formula sheet. This we are going to use mainly in article 8.1 and 8.2. 8.1 and 8.2. Simultaneous linear equations, when roots are real and distinct, roots are real and repeatable, what would be the situation? Not just for one equation, just for a couple or 2, 3 equations. Need simultaneously more equations, right? So that time we are going to use this formula sheet. How to utilize, how to make use of this formula sheet, I will let you know. I will let you know. Probably you will not come to know mainly the second part, but I will let you know when the time will come. Okay, question number 1. Read this question twice. Read this question twice. A mass weighing 2 pounds stretches a spring 6 inches. If it is possible, try to take the picture of this example in your cell phone right now. If it is possible, try to take the picture of this example in your cell phone so that when I start the example, at that time you won't face any problem. Just take the picture of this one. Okay. Done, guys? A mass weighing 2 pounds stretches a spring 6 inches. 6 inches. At t equal to 0, the mass is released from a point 8 inches below the equilibrium. Here it is given in terms of inches. Here it is given in terms of inches. Below the equilibrium position. Below the equilibrium position. Equilibrium position is this one. Below means it is in the direction of the gravitational force. Right? There are 2 types of, I'm going to say, release from 8 below. Another is above the equilibrium position. With the upward velocity 4/3 feet per second square. Velocity is always feet per second square. Determine the equation of motion. The main thing in this example is, you can see over here, the mass weighing 2 pounds, that's fine. W is equal to 2 pounds, you can say. W is equal to mg. M equal to W over G. W equal to 2 pounds. This one is given, stretches the spring in 6 inches. This is inches. At t equal to the initial condition is given to you, that is 8 inches. But your velocity is given in terms of not inches, that is given in terms of feet. You cannot work with 2 different units. You have to convert everything in terms of either inches or feet. I would like to convert these inches and this 6 inches and 8 inches in terms of feet. 6 inch means it is 1/2 feet. Agree? 6 divided by 12. Make sense? Because 12 feet equal to 1 inch. 8 divided by 12 means, yes, 3/4 inches. Am I right? Sorry. 4 2s are 8 and 4 3s are, right? So it is how much? 8 by 12. How much? 2 by 3, right? 2/3 inches. So first convert this unit before you start with the example. Determine the equation of motion. What would be the equation of motion? You have a picture, so let me close this one and let me again go back and let me start with the example. Okay. So, example. Yes, who? Margie, read the example.
For Newton's second law.
All right, sir. I gotta go. Have a
Yeah,
good
go
day.
ahead, please. I don't know why. Go ahead. Yes. Who wants to take this example, guys? If you have that example, I told you to take the picture, right? You guys took the picture. So please read that example for me.
Okay, I found it.
Okay.
A mass weighing 2 pounds stretches a spring 6 inches at t equals 0.
Wait. Mass weighing 2 pound. See, I wrote it down like this. W equal to 2 pound. Stretches the spring in 6 inches. So 6 inches. But as I told you that velocity is given in terms of feet. So let me convert to feet. So 6 by 12 equal to 1 by 2 feet. Go ahead.
At t equals 0, the mass is released from a 0.8 inches below the equilibrium position with an upward velocity of 4/3 feet per second.
Wait.
Determine
Okay.
the equation of motion.
Right. So x at 0, when time t equal to 0, it is 8 inches. 8 inches means, as I told you, 8 by 12, so 2/3 feet. Velocity means x dash at 0. It is now 8 inches below the equilibrium position. Below means it is in the direction of the gravitational force. That means we are using plus sign. So it is plus 2/3 feet. But upward velocity is upward in the reverse direction of the gravitational force, and that's why we are using negative sign over here. Please keep in mind this thing. The initial conditions are given to us. Second order differential equation, you have to have two initial conditions, and that's what we have. One is the displacement condition, one is the velocity condition. Displacement condition is given to you, that is below equilibrium position. That means we are using plus sign because that is in the direction of the gravitational force. And velocity is given in the upward direction, that is the reverse direction of the gravitational force, gravity, and that's why we are using the negative sign. That's the only important part over here. W is equal to mass weighing 2 pound, that is the first line. So W is equal to mg. So naturally, m equal to W over g. Mass weighing 2 pound, it's not mass, it's mass weighing 2 pounds, so W is equal to 2 mg. Please keep in mind this thing. Using that one, I'm going to find my mass of the object. So suppose W is equal to, m equal to W over g. W is 2, g is equal to 32. 2 over 32. So that is equal to 1 over 16 slug. 1 over 16th slug. Right, guys? 1 over 16 slug. Unit is slug. So always keep in mind this thing. Always please keep in mind this thing. 1 over, always, whenever you are finding your mass, it is in terms of slug. Hooke's law, that is F equal to Ks. Hooke's law we are using just to find the spring constant. In some of the examples, spring constant will be provided to you. Whenever spring constant is provided to you, at that time you are not using this Hooke's law because already spring constant is with you. Here the spring constant is not given in this example, but we require that one for the equation of motion, and that's why we find this spring constant using Hooke's law, F equal to Ks. Whatever mass weighing 2 pound is given to you, that weighing 2 pound, that is the force, so that is 2. K we are looking for, and S is stretching, that is 1 by 2 feet. So K equal to 4 lb per feet. K equal to 4 lb per feet. Second order differential equation for free motion without damping is m into d square x by dt square plus kx equal to 0. If you remember, we ended up with this equation after that spring figures, 3 figures. M, I figured it out, mass is 1 over 16 slug, d square x by dt square, k constant is 4, x equal to 0. T is the independent variable, x is the dependent variable, depends on t. If you multiply throughout by 16, you're going to get d square x by dt square plus 64x equal to 0. This is the second order differential equation with right hand side non-zero, means article 4.3 Auxiliary equation will be m square plus 64 equal to 0. Because plus sign is there, means m equal to plus or minus 8i. Because of plus sign, you are getting m equal to plus or minus 8i. If you compare with alpha plus or minus I times beta, your alpha is 0 and beta is 8. So roots are complex conjugate of each other. Rule number 3 or category 3. That means xct, of course, xc complementary function will work as the solution because right hand side is 0. So xt, e to the power alpha t, alpha is 0, so it's 1. C1 cosine bt, beta is 8, plus C2 sine bt, beta is 8. We have two initial conditions, x1, x0 and x dash 0. Plug these two values over here one by one. First plug the first condition, displacement x at 0 equal to 2/3 feet. So x at 0 equal to 2/3 feet, 8 inches, right? Yeah, so 2/3 feet. So when t equal to 0, it is 2/3, C1 0, cosine 0 is 1, sine 0 0. So C1 equal to 2/3, go back and plug it back over here in the last general form. So my C1 is 2/3. So I'm getting xt equal to 2/3 cosine xt plus C2 sine 8t. 2/3 cosine 8t plus C2 sine 8t. My second condition involves the derivative because that's the velocity condition. Means I have to have the derivative of this final general solution. So x dash t equal to -2 cosine 8t chain rule, 8 -8 sine 8t, 8 cosine 8t. So x dash t equal to this one. Second condition says that x dash 0 equal to -4/3, replace t by 0. So left side is -4/3, sine 0 is 0, cosine 0 is 1, that is C2 times 8. So naturally, if you simplify this one, C2 equal to -1/6. Go back and plug this value in your last equation, xt equal to 2/3 cosine 8t and C2 is -1/6 sine 8t. That is your general solution equation of motion, or the solution for the equation of motion is this one actually. Equation of motion is this one. Solution of equation of motion, that is this one. Xt is this one. So that's how this spring mass or second order differential equation is being used in spring mass system. Any doubt, guys, in this example? Any doubt, guys? Look at this example twice. I give you a couple minutes and then after we can start the next example, probably one or two more examples and then the review session. Then we'll stop. Shall we go for the next one, guys? Second example, third example, and fourth example is similar to example number 1. So I will not solve this one. Of course, it is there, solution is with you. Yeah, so let me go through these two examples and we'll stop. So first, again, let me go back and try to open the question. So where I was here, not here, here, yes. Question number 1 is done. Question number 2. Paul Mustaine, read the question.
A mass weighing 4 pounds is attached to a spring whose spring constant is 16 pounds per feet. What is the period of sample harmonic motion?
Look at here, guys. Question is completely different. I'm not asking you the equation of motion. It is the period of simple harmonic motion. Period means now I'm asking you capital T. Capital T was 2 pi over omega, right? And omega was square root of k by m. Spring constant k is already provided to you. It's just 3-4 steps answer and you're done. Are you getting me, guys?
Yes, sir.
Let me give you the answer. Look at here. For LB, W is equal to mg, m equal to w by g, 4 over 32, 1 over 8 slug. Actually, we don't want this thing, but that's fine. Period of simple harmonic motion, we are looking for t equal to 2 pi over omega. Omega is equal to square root of k by m. Spring constant k is 16. No, actually, we want this thing. I'm sorry. 16 is given to you, and m, mass, we just figured it out, 1 over 8 slug. I'm sorry. Yeah, we want this thing. So 16 multiplied by 8 is 128. So W square is 128. So W is equal to 8 square root of 2. Go back and plug it over here. So T equal to 2 pi over 8 square root of 2. So that is equal to root 2 pi. You are given the unit in terms of seconds. So write down second and you're done. Simple. So please make sure whatever is given to you, what you are looking for. So T equal to root 2 pi over 8 second. Root 2 pi over 8 second. Good. Let me go back. Any doubt in this example too? Any doubt in example 2, guys? Okay, let's go back. Example number 3. Will?
You want me to read it, sir?
Yes.
All right. A 20 kilogram mass is attached to a spring if the frequency of a simple harmonic motion is, can't read it, 2 over
2
pi
over pi cycles per second.
cycles per second. What is the spring constant K? What is the frequency of single harmonic motion if the original mass is replaced with an 80 kilogram mass?
Right, guys? First of all, you need to pick up your word, pick up the words. It's not gram now, it's 20 kg. But everything is given in terms of kg. That's fine. Simple harmonic motion, 2 by pi cycles per second. If the frequency f is given to you, 2 over pi. If frequency is given to you, that means naturally you can find your capital T because frequency is nothing but 1 over capital T. So you can find your period, right? Okay, 20 kilogram mass is given to you. What is the spring constant K? Yep, because omega is nothing but omega or omega square equal to K divided by M. M is given, M you can find from here. Omega you can find from here, 1 over capital T equal to omega square plus capital T equal to 2 pi over omega. You can find omega from there. Plug the values. What is the frequency of simple harmonic motion if it is replaced by, if 20 is replaced by 80? Simple question, guys. Look at here. Very simple answer. (20 kg). Mass equal to 20 kg is given to you. F equal to 2 over pi cycles, right? What is the spring constant? That's the question. As I told you, F equal to 1 over capital T. 1 over capital T. Capital T is nothing but omega over 2 pi. So, sorry, 2 pi over omega. If you plug this value over here, because it is reciprocal, 1 over T, so you're going to get omega over 2 pi. And frequency is given to you 2 over pi. That means this pi and pi will get cancelled out and you are getting omega equal to 4. Once you find your omega equal to 4. Omega square equal to k by m. You are looking, don't forget you are looking for k, spring constant. Omega square equal to k by m. M is 20. Omega is only with you 4, so omega square is 16. So k equal to 16 multiplied by 320 kilometer per cycle. Second part says that if your mass is 80 kilogram, then what is the frequency? If mass is 80 kilogram, T equal to 2 pi over omega, omega is equal to k over m square root. Replace, now already you fixed your spring constant. It won't be changed. So spring constant is k equal to 320. So let me write 320 over here, and mass m equal to 80. Because now m is 80, not 20. That means I'm getting my omega equal to 2. Once I get my omega 2, my T will be 2 pi over omega. So it is pi. So frequency is equal to reciprocal of T, 1 over pi. Simple. Any doubt in this example, guys? Any doubt in this example? No. Question number 4 is simply parallel to question 1. Question number 5 is slightly different. And that's why I did not take that one. Question number 5, that we will be taking question 5 onwards next time, right? So let me stop sharing this one, or no, let me close this one and let's start the review session. So stop sharing and let's start the review session. Any doubt, any question in your chapter 4? If you have any question, you can ask me.
My biggest issue, sir, is just finding the roots. So the format
roots?
for solving, yes, sir. The format for solving stuff is pretty simple once you figure out what condition you need to obey. But like getting there and solving for the correct roots and then using the right condition is what I struggle with.
That means your problem is article 4.3. That's what you mean?
Yes, sir.
Give me one example. Any example. You can give one example.
Just a minute, sir. I'll have to find one.
Okay, take your time. Let me share the screen first so that I can start immediately answering your question. Okay, go ahead. Any one of you guys, give me one example. Just one example.
Sir. Question 4F from the practice test. I understand how to get it to.
No. Give me the problem.
Okay, it is. Solve the following differential equation by the method of undetermined coefficients.
You are asking me now question 4. You have question, I'm sorry, 4.4. 4.4 or 4.3?
Okay. My issue, sir, is just finding roots. So we in both of those, I believe we turn it into where we'll have the
give me that
the
example.
auxiliary equation. Okay.
Give me that example.
Y double prime minus 8y.
Wait. Y double prime minus
8y prime plus 20y equals 100x squared minus 26x x times e to the x.
Okay.
And once we get the auxiliary equation, which is, I believe, m squared minus
Wait.
8.
Wait.
Okay.
First of all, your operator form is d square minus 8d plus 20 outside y equal to 0.
Right.
My auxiliary equation is m square minus 8m plus 20 equal to 0. Agree?
Yes, sir.
M square minus 8m plus 20 equal to 0. You are asking me right now 7th grade problem. This is ax square plus bm plus c equal to 0. Quadratic form. Agree?
Okay. So we just plug it in the quadratic formula
Yes.
and get the answers from
Quadratic
that.
form.
Okay.
What is the
Okay.
solution of the quadratic form? Solution of the quadratic form, x equal to negative b plus or minus square root of b square minus 4ac divided by 2a. Agree?
Yes, sir.
Right? What is your b here?
8.
What's your b?
8.
It's negative 8. It's not 8.
Negative 8. Okay.
Make sure, otherwise you'll be wrong. So negative and negative will be positive, so here it is 8. Plus or minus square root of b is 64. Minus 4. What is your a? Your a is
1.
1. So 64 times 1. 64 times 1. And c is C?
20.
20. So here it is 20. And divided by 2a, a is 1. So that is equal to 8 divided by 2 is 4 plus or minus 64 minus 4 to the 20. 64 minus 20 means negative 16 divided by 2. Agree?
Yes, sir.
That is equal to 4 plus or minus. There is square root of 16 is 4 and square root of negative 1 as it is divided by 2. Oh, sorry. So that is equal to 4 plus or minus 2 and 4. So here it is 2 and square root of negative 1 is I. So 4 plus or minus 2i, that is your auxiliary solution of the auxiliary equation. Makes sense? That means your roots are complex conjugate of each other. Look at over here. One root is 1 plus 2i, second root is 4 plus 2i and 4 minus 2i. So complex conjugate, that means that is rule number 3. Article 4.3. Article 4.3, rule number 3. Agree?
Yes, sir.
And that says that if you have complex conjugate roots, that means your yc of x, that is equal to e to the power alpha x inside the bracket c1 cosine beta x plus c2 sine and beta x. You can see, you can compare this one with your alpha and beta. So this is nothing but alpha plus or minus I times beta. Alpha plus or minus I times beta. So alpha equal to 4. So you can write that is equal to e to the power 4x and c1 cosine of beta equal to 2. So 2x plus c2 sine of 2x. That is your auxiliary solution. Does it make sense?
Yes, sir.
That's
Yes,
what you
sir.
want, right?
It is. It is.
Okay. And then after, if you want to move ahead, if you want to go with this example, may I erase this part? Whatever I wrote it down by red pen.
Yes, sir.
I erase this one.
Yes, sir. And I believe you have the I believe that the solution to this question is already up on Canvas.
Okay, that's okay.
I just wanted to make sure, clarify, how we got those roots.
Okay,
So that was my question. Thank you.
no problem. So, but even though, let me just give you the hint. Let me just erase some of the things over here. It is 100x square minus 23. Let me 100x. Give me this right side. Okay, again, let me erase everything. Clear? Okay. Now my YP. What was my right hand side? Oh, sorry. What was my right hand side? 100.
Right hand side was
100x square minus 20 x e to the power x. Something like that.
was
Yes or no?
Minus 26x e to the x. Yes,
Or
sir.
26. That doesn't make any difference. That's fine. 26. Okay, no problem. So assume my yp equal to, assume yp equal to, this is a quadratic form. Quadratic form, that means I can write ax square plus bx plus c plus, here is the product, plus, I don't write d, so ex plus f and e to the power x or 2x, e to the power x, right?
Yes, sir.
E to the power x. So this should be my yp. My solution for yc was, solution for yc of x was, help me, it was c1 cosine, no, e to the power 4x,
Mm-hmm.
c1 cosine 2x plus c2 sine 2x, right?
Yes, sir.
Because it is e to the power 4x here, I don't have any e to the power 4x, it's e to the power x. So no glitch for this part. Here is the exponential function, there is no exponential function, so no glitch. That means I can say no glitch. I can say no glitch. My left hand side, the highest derivative here, for left hand side, whatever I had, my highest derivative is 2. So I can go for yp dash and yp double dash. Find this one and non-glitch part, all these three values, just go back and plug it over here, compare with your right hand side. If you are doing this thing and if you write your equation correctly, if you compare your coefficients correctly, that means you are getting the value of all your constants A, B, C, E, and F. You are going to get four equations, right? Those four equations equal to something, one equal to something, something, equal to something, equal to something. And then after you can use matrix, right? And then go for R, REF. Sorry, it's actually small, R, REF. That RREF will give you the values of all these four constants. Finally, go back to your YP. Whatever constants you have found, just go back and plug it over here in your YP here. So you are getting some YP. And the general solution is given by Y equal to YC plus YP. Make sense?
Yes, sir.
Okay.
Sir, on the practice test, there were more of these problems than any of the others. Will that be the same on the test tomorrow? Will these be the majority of the
majority?
the
Yes.
exam?
Majority, yes. That's the right word. Majority. Yes.
Okay. Okay.
Any other doubt, guys? Feel free, guys. I'm here to help you out. Feel free. May I erase this part? May I erase?
Yes, sir.
Okay. Any other doubt? I know it's simple. We went over everything, mostly everything. Very couple, 3-4 examples I just gave in homework, and I think those examples are also solved in our assignment. So you have everything with you. Just you need to work hard. You need to understand the concept. Make sure that when you write your exam at that time, your teacher, he doesn't know anything. So your language will be a convincing language. Don't write in a rough way. Last time I just got very minor points, 1 or 2 points because of rough writing. I mentioned that thing in few of the exams. But this time I won't allow you. Instructions should be given only once or twice, not more than that, right? So even though I'm informing you in advance, so whenever you write the things at that time, make sure that you are writing everything. Don't forget left-hand side. So many people, they don't want to write the left, just like exact differential equation. Most of you guys, they don't want to write 1 over m del n by del x minus del m by del y, and you just plug the values directly, and it was hard for me to understand that part. Don't give me hard time, because my hard time will decrease your points. So please don't do this thing, please. I request you, please. Smooth and understandable writing, that is the best way to get the good grades. Any question for me, guys?
Sir, I have a question.
Go ahead.
On question number 4, do you not want us to write the answers YP? You just want us to put the YP plus the Y of C?
You have to, because general solution that is given in the form of YC plus YP. So only if you write YC plus YP, that's not enough. You have to plug those values, whatever you found your YC, and then after YP, both the values should be there just in one line. So you have to write your general solution, otherwise it is -1 or -2. So make sure, please, please, please. Next.
Thank you.
Next, guys. Any question? Gage Levine, any question?
Not right now, sir.
Now probably I will be paying more attention on you throughout this session. So please be attentive, be particular every time. Okay? I maybe ask you a little bit more questions than others. I hope you understood me, right?
Yes.
Gage Levine, I'm asking you.
I don't have any questions at the moment, sir.
Okay, that's fine. So hopefully you're going to get full points tomorrow, right?
I think so.
Because you don't have any questions. Anyway, guys, girls, any question? Nina, Margie?
No, sir.
Nope.
Okay. Any other guys? My dear friend, Harris? Will is good. Okay. Nathan Light. Yes, I forgot you. I'm sorry. Nathan Light. Any question for me?
No, I don't have any questions.
Okay. Smile is not here. I don't know what he wants to do. I'm really upset with him. I don't know. Anyway, so if you have any doubt, guys, please let me know. Otherwise, let's stop here. I thought this review will go at least for 20-25 minutes, but no, we just wind it up in 15 minutes. But that's fine. Shall we stop here, guys? Say something. I'm asking you.
You can.
Okay.
Yeah, I think we're good, sir.
Okay, guys. So let me do one thing. Let me let me stop sharing all these things now. And good luck to you. I'll see you tomorrow at 9:45. Right, guys? Again, I would love to spend 5-10 minutes with you guys if you have some last minute questions for me. And then after we will start the exam. Exam is for 1 hour. Last 10 minutes for your submission to Canvas. Again, let me remind you, I just want 2 files. One is for exam, one is for homework. Don't send multiple files, please. Just 2 files. Shall we stop here, guys?
Yes, sir.
Queen Heart. Queen Heart. Shall we stop
sir.
here? Thank you. Guys, take care, stay safe, work hard. Okay?
See you tomorrow, sir. Have a good day.
You too. Thank you, guys.
Sir, were you
Thank
able to
you.
grade my homework?
I did. When did you submit?
Well, I had to. I didn't know we were supposed to submit it upload it to the test board.
Okay, I will.
So you haven't
I will look at that one today.
Or it should be in your email around 12 o'clock.
Oh, email? No way, no way. You have to submit to Canvas. No,
Well, it was closed when I went back to it.
this is not fair. This is not fair. I gave you ample time, right? Enough time I gave you to ample opportunities. Enough time was given to you.
Well, no, I'm saying
Anyway,
that
let me
we were supposed
let
to
me see what can I
upload
do
it to
for
the
you.
test. Okay.
That's fine.
All right.
Let me see.
Thank you.
Okay, guys, take care. Bye. See you.